In the second case, let's consider this is a simple pendulum. So this is the pendulum. Let's say this is the bob, as you can see at a point, and obviously this circular point or circular object is a pendulum. Anyways, this pendulum is moving through A to B, B to C, again C to B, and then again A. What you have to do, we have to prove that at A, at B, at C, at every single point where the total energy, it means the mechanical energy, is equal. In that case, we can say the law of conservation is maintained. So our very first task is to calculate the total energy at point C. At point C. At point C, so here let's say there is height is PA from P to A, and up to B the height is A to M, and from B to C, the height is NM, right? Hope you understand this thing. So the very first A to B height is AM, and then B to C height is MN or NM, and the total height, which is the length of the cord or length of the string, which is PC, PB and PA, these are equal, right? Now at C point, the pendulum need to be released from C. So at C point there is maximum potential energy. So potential energy at C point is mg, and height is, as I said, an, so it need to be right a and n, right? And at this point, at C point, it is actually stopped at this point and then released, right? Indeed, at C point there is no velocity, so Vc is equals to 0. Indeed, kinetic energy at C point is 0. So the total energy at C point is equals to E PC plus EKC. So the value is mg an. So the total height will be an. Now it's time to evaluate the value at B point. At B point, so at C point there is velocity Vc is equals to 0. At Vb equals to, we can write down actually, V square equals to Vc square plus 2g, and height is how much? This height is mn, so we could write down here m and n. Now it's time to write down the potential energy at B point. So EPB is equals to mg, and height is how much? Height is this much from the bottom, so it will be am. So we have to write down here a and m, and the kinetic energy EKB is equals to half m v b square. So at Vc it is 0, so we can write down 2g m n. So we could write down here half m, and VB square means 2g m and n. So these two cancel out. So we could write down mg mn. So the total energy at B point, we could write down EPB plus EK EKB. So EPB is mg am plus mg mn. So this is EKB and this is EPB. So we could common mg part, then we could write am plus mn, and here we can see am plus mn, all together we could write down an. So the total energy we can write down mg an, right? At a point, the ground point actually, at a point there is no height. Indeed there is no height, so h is equals to 0. So at this point EPA is equals to 0 and EKA, the kinetic energy at a point, will be half m VA square. So when it is traveling from B to A, so here at a point the velocity is VA, and at initial point for this case coming from B, which is actually VB, and we have already evaluated the value of VB square actually, which is VB square is equals to 2gmn. So instead of VB we could write down 2gmn, right? So VA square equals to VB square plus 2g, and there is no height traveled, is it? Of course there is some height traveled. How much height traveled? From B to A, which is actually AM. Let's write down here AM. So the value of VB, which is actually 2gmn, so we have to write down here, instead of VB square, 2gmn plus here 2g am. So 2g part is common, so here mn plus am. So mn plus am, so up to this much mn or nm to am, all together we can write down an. So instead of mn we could write down an. What left? 2g. So VA square is equals to 2g an. Now it's time to write down here half m, and a square means, VA square means 2g an. So these two cancel out. So we could write down mg an. So at every point, if we look back, actually, we can find out the total energy is mgn. By the way, for a point, what can we write? That is ea is equals to pa, potential energy at a point, and kinetic energy at a point. So this is 0 and this is mg an. So ea equals to mg an. So at every point we found that ea is equals to eb is equals to ec is equals to mg an. So the law of conservation is maintained at every single point because the mechanical energy for every point is equal. So at C point, mg an, at B point, same mg an, and A point as well, mg an. So the law of conservation is maintained for this simple pendulum.